So next property is called humidity ratio or specific humidity. So it is one of the important psychometric property, and it is represented as omega. It is represented as omega. This humidity ratio or specific humidity is defined as the ratio of mass of water vapor of the given moist air at a given temperature to the mass of water vapor of dry air So the ratio of mass of water vapor to the mass of dry air in the given moist air is known as humidity ratio or specific humidity, and it is given as mV by mA. We know atmospheric air or moist air is a mixture of water vapor plus dry air. The ratio of mass of water vapor by the mass of dry air is known as omega. And mass of water vapor, we will get volume of water vapor by specific volume of water vapor. Similarly, volume of air by volume of specific volume of dry air. Then volume and getting answer. Then this can be also defined as specific volume of dry air to the specific volume of water vapor. It is for omega definition, right? As we know, characteristic gas equation PV equal to mRT, or this volume by mass is called specific volume, P small v equal to RT, right? If it is applied for the dry air, then it is PA VA equal to RAT. Similarly, if I apply for water vapor, then PV V equal to RVT. So this is dry air and this is water vapor. Right? From this, if I take VA value, then I will send this PA term into the right hand side. Then it is RAT by PA. In the same manner, if I write only V of water vapor, then it is RVT by PV. Let it be equation 1 and this is 2, right? These equation 1 and 2 substitute in the definition of omega, that is VA by VV. What is VA? So VA is RAT by PA divided by VV. This term RVT by PV, where temperature getting answer, temperature getting answer. Then the final expression omega is given as PV RA by PA RV, right? We know gas equation PV equal to mRT. Similarly, the characteristic gas constant R is given as RU by capital M, where RU stands for universal gas constant, which is 8.314 kilojoule per degree mole Kelvin, whereas M is called molecular weight of the element, molecular weight of the gas element. If I write RA, then it is RU by MA, where molecular weight of dry air, it is 28.97 joule per degree mole Kelvin, and RV, then it is RU by MV, where MV is called molecular weight of water vapor, which is equal to 18.016 degree mole Kelvin, right? Then substitute this RA value, RB value in the above equation. Therefore, omega is given as, so PV into, instead of writing RA, I will write RU by MA divided by, instead of writing so we need to write, so PA, then RV, instead of writing RV, so the equation is RU by MV, RU by MV. So universal gas constant, so these two getting cancelled, then so equation is PV into, this is in the denominator, so move into the numerator, by PA into MA. We know MV, MA value, so substitute, so PV into MA value, it is 18.016 divided by PA into 28.97, right? So if it is simplified, then we are getting 0.667 PV by PA. According to the Dalton's law, according to the Dalton's law, so the total pressure is always equal to the sum of the partial pressure exerted by the elements. So P equal to PA plus PV. So this is Dalton's law. So from this Dalton's law, if I write PA, what do you mean by PA? Partial pressure exerted by the dry air, which is equal to total pressure minus partial pressure of water vapor, right? Then substitute the PA value in the final equation. So final equation for omega is 0.667. So PV by PA. So 0.667 PV by, instead of writing PA from Dalton's law, we will get P minus PV. In the above equation, so P is called as total pressure of the atmospheric air, where PV is called as partial pressure of water vapor, and P remains constant as atmospheric pressure is constant, which is equal to 1.01325 bar or 760 mm of Hg. So omega mainly depends on partial pressure of water vapor. So omega is a function of partial pressure of water vapor. Higher the partial pressure of water vapor in the atmospheric air, more will be the omega content, right? So humidity ratio or specific humidity is measured in terms of partial pressure of water vapor, and analytically, so we can evaluate by using this equation. Omega is given as 0.667 PV by P minus PV, where PV is called as partial pressure of water vapor, where P is called as total pressure of the atmospheric air. And this is basic definition. Omega is given as mass of water vapor by mass of dry air in the given moist air, and it is measured in terms of kg of water vapor by kg of dry air, right? So this is all about humidity ratio or specific humidity. The next property is known as relative humidity. Relative humidity, and it is represented as RH, and in some of the textbooks it may follow phi also. Relative humidity. What do you mean by relative humidity? Means it is the ratio of mass of water vapor at given temperature to the mass of water vapor when the air is at saturated condition. That means if you take the ratio of mass of water vapor for unsaturated air at a given temperature to the mass of water vapor when the same air is at saturated condition, so it is the ratio of mass of water vapor to the mass of vapor when it is at saturated condition. That ratio is called as relative humidity, and it is measured in terms of percentage. The relative humidity expressed in terms of percentage, right? So again you need to apply characteristic gas equation. So for water vapor unsaturated condition, so MRT, and for saturated air, so it is PSV equal to MSRT, RT, right? Then I will write MV by MS. Then from the above two equations, if I write MV by MS, then it is PV V by RT by PSV by RT. So RT getting cancelled, VV getting cancelled, then it is PV by PS. So relative humidity is given as PV by PS and is expressed in percentage, so you need to multiply with 100. Temperature for water vapor at saturated condition, unsaturated condition, temperature or gas constant and volume remains same, so these will be cancelled. So only left in the numerator denominator is PV by PS. So PV by PS into 100, this is the empirical equation to calculate relative humidity, and it is expressed in terms of percentage, that's why we need to multiply with 100. So relative humidity is the ratio of mass of water vapor for unsaturated air to the mass of water vapor when it is saturated condition. That ratio is called as relative humidity. Then we are having another psychrometric property called as degree of saturation, and it is represented as the letter mu. Degree of saturation is represented by letter mu. So what is degree of saturation means? It is the ratio of specific humidity of unsaturated air to the specific humidity of saturated air. We just now discussed about humidity ratio for atmospheric air and moist air. If you take the degree of saturation, so it is the ratio of specific humidity of unsaturated air to the specific humidity of saturated air. So for unsaturated air, the equation is 0.667 PV by P minus PV. Whereas for saturated air, so it is 0.667. Instead of writing PV, we need to write PS. That is the only difference. P minus PS. So 0.667 getting answered. Then the equation is PV into P minus PS divided by PS into P minus PV. So this is given as mu. So in the numerator denominator we are having pressure unit, so it is unitless parameter. So degree of saturation does not have any units. So it is better to calculate the individual value of omega and omega for saturated air. Then if you substitute, you will get mu value directly. Then the last psychrometric property is called as enthalpy. Enthalpy of air. So it is represented as H, small h. Energy available in the moist air generally referred as enthalpy. And as you know, moist air is a mixture of dry air and water vapor. The enthalpy is calculated as enthalpy of dry air plus enthalpy of water vapor. The enthalpy of dry air is calculated as Cpa into Ta, where Ta is called as dry bulb temperature, Cp is called specific heat of dry air, plus water vapor mainly depends on omega. So omega into 2500 plus 1.88 T, where T is called as dry bulb temperature. So enthalpy of water vapor is calculated as enthalpy of dry air is calculated as Cp of air into temperature of air, and the enthalpy of water vapor is calculated as specific humidity times 2500 plus 1.8 into temperature. So temperature means dry bulb temperature. It is in degrees centigrade. So this is the equation used to calculate enthalpy of moist air. So overall, if you summarize, the atmospheric air is a mixture of dry air and water vapor. Atmospheric air mainly contains several gaseous elements such as nitrogen principally, followed by oxygen, carbon dioxide, inert gases. In addition to that, we are having water vapor. So air plus water vapor, it is called as moist air. Generally we named as atmospheric air. So you must know three definitions. One is called as dry air, moist air, and saturated air. What is dry air means? The air without any water vapor, it is referred as dry air. And dry air mainly contains the gaseous elements like nitrogen, oxygen, carbon dioxide and inert gases. So air without any water vapor, it is referred as dry air. Then moist air, the name itself, so air contains moisture. So air with water vapor, it is called moist air or humid air. So in the nature, we are having only this moist air. The air will not be found anywhere, right? So in actual, it is called as moist air, or atmospheric air is called as humid air. So air with water vapor is called moist air. Air without water vapor is called as dry air. Then what is saturated air? It is the condition of air where the air can hold maximum amount of water vapor in it. It is called as saturated air. So when air accumulates the maximum amount of water vapor, air absorbs more amount of water vapor, it is called saturated air. So saturated air is the condition of air at which air can hold maximum amount of water vapor. It is referred as saturated air, right? So we need to solve the psychrotic problems by using the psychrotic properties. Then it is called as analytical method. And psychrotic problems can be easily solved by a process called as by a graphical process called as psychrometric chart. So any problem given on psychrometry, there are two approaches we need to solve. One is called as analytical method by using these empirical relations of psychrotic properties, and another simple approach called as graphical approach. It is called as psychrometric chart. Let us see psychrometric chart. So psychrometric chart. So what is psychrometric chart means? It is a graphical representation of various properties of moist air, right? A graphical solution to solve any kind of psychrometric properties of air, it is called as psychrometric chart. So psychrometric chart does not use any empirical relations to get the required properties of air, right? So it eliminates the various calculations involved in psychrometric analytical method. It is very simple method, but whatever the solution obtained from the psychrometric chart, those are approximate only. Whereas if you use analytical method for psychrometric problems, we will get exact values. So psychrometric chart is constructed by taking x-axis is dry bulb temperature dBT, it is degree centigrade. So let it be 5, 10, 15, 20, 25, 30, 35, and these lines are vertical. All the vertical lines on psychrometric chart is dry bulb temperature lines. These are vertical lines. Whereas there will be curved on extreme left corner. So it is called as saturation curve. It is called as saturation curve, where relative humidity is 100%. Where relative humidity is 100%. If you draw number of curved lines, this is 90% relative humidity line, then 80%, 70%, 60%, 50%, 40%, 30, 20, 10. So all the curved lines on psychrometric chart indicates relative humidity lines. These are relative humidity lines. As we are moving away from the saturation curve, relative humidity value goes on decreases, right? Relative humidity lines are curved lines are called as relative humidity lines. These are 100% on saturation curve, and these values will be reduced when it is moving away from the saturation curve. Then in the y-axis, so these values are called as specific humidity lines, and these lines are horizontal in nature. If you draw any horizontal line on psychrometric chart, so it indicates constant specific humidity values or humidity ratio values. These are humidity ratio values. There will be scale is given, so like 0.001, 0.002, 0.003, 0.004, 0.006, 0.008, 0.01, etc. Right? It is kg of water vapor to the kg of dry air. So horizontal line on psychrometric chart indicates constant omega values, right? So on the saturation curve, whatever the dBT values are found on x-axis, same value will be represented here. This is 5, it is 10, 15, 20, 25, 30, etc. Right? When you draw any horizontal line towards saturation curve, so whatever the value obtained on the saturation curve, those lines are called as dBT lines. Dew point temperature values. Dew point temperature value. That means on the psychrometric chart, a horizontal line will indicate two properties. When you move towards right hand side, whatever the value obtained on this vertical axis, so vertical parameter, it is called omega. So on right hand side we are getting the omega values. When the horizontal line is extended towards left hand side, wherever it is intersecting this saturation curve, the respective point is called as dew point temperature, and it is in degree centigrade. It is in degree centigrade. Later there will be number of inclined lines of equally divergent, equally spacing. There will be inclined lines on psychrometric chart which are equally divergent, right? And these inclined lines on psychrometric chart called as WBT lines. It indicates wet bulb temperature lines. So inclined lines on psychrometric chart are called as constant WBT lines, right? Constant WBT lines. And if you extend these WBT lines above the saturation curve, if you extend, then there is a scale is given. There is a predefined scale is given, which is called enthalpy. It is kilojoule per kg. Enthalpy scale. Let it be 30, 35, 40, 45, 50, and so on. So inclined lines within psychrometric chart, these lines are called as WBT lines, and if we extend above saturation curve, so there is a predefined scale called as enthalpy value. So in psychrometric chart, enthalpy lines, WBT lines are one and same. Within psychrometric chart, inclined line is called as WBT line. Outside the saturation curve, it indicates the enthalpy values. Finally, so there will be more divergent, more inclined, more slant lines are represented, and these are called as specific volume lines. These are known as specific volume lines. Specific volume lines. Specific volume lines is represented as 0.85, 0.9, 0.95, etc. Right? More divergent, more inclination lines are called as specific volume lines. So this is the representation of psychrometric chart with various properties. On the right hand side of the psychrometric chart, there will be a scale called as sensible heat factor scale or sensible heat factor scale, which is given as 1.9, 0.8, 0.7, 0.6, 0.5, 0.4, 3, 2, 1, 0. So there is scale range from 0 to 1. What do you mean by sensible heat factor? So sensible heat factor is the ratio of sensible heat to the sensible heat plus latent heat. This sensible heat plus latent heat is called as total heat, right? So it is called as sensible heat factor. While evaluating air conditioning problems, cooling load problems, so sensible heat factor is one of the important parameter you need to consider. For that, you must know what do you mean by sensible heat factor. So it is the ratio of sensible heat by sensible heat plus latent heat. So we are getting some fraction. So that value will be represented on the right hand side of psychrometric chart. There is a predefined scale is given which is called a sensible heat factor. You know the meaning of sensible heat and latent heat. Whenever heat interaction taking place, because of heat addition or heat rejection, if temperature change occurs, it is called sensible heat, which is evaluated as mCp delta T, right? Whereas if heat interaction involvement causes change in phase from vapor to liquid, liquid to vapor, or liquid to solid, solid to liquid, vice versa, then it is referred to be latent heat. So when heat interaction or heat rejection process occurring, there may be chance of increasing or changing temperature, it is referred as sensible heat. There may be chance of changing the phase, it is called as latent heat. We need to identify and evaluate sensible heat and latent heat involvement in the heat transfer process, and you need to evaluate sensible heat. So this is all about psychrometric chart. So once you know the construction of psychrometric chart, then it is easy to solve any kind of psychrometric problem by using this graphical method called a psychrometric chart. So if you want to evaluate the psychrometric properties by using this graphical chart, we require at least two properties of moist air, whether it may be dry bulb temperature or wet bulb temperature or relative humidity or dew point temperature omega. If you know two properties, we can evaluate all the remaining properties very easily by using this graphical method. Thank you.